Today we will go over section 6.6, which is operations with algebraic vectors in R squared. In this section, we will deal with vectors in xy plane and learn different representation of OP equaling to AB, let's say that format. Now, instead of using the coordinates, we will represent this in terms of unit vectors. Unit vector I represents x component, while unit vector j is going to represent the y component. Now, these two unit vectors have a magnitude of 1 and they lie along the positive x and y axis. That's why as a magnitude for, let's say, I representing x component, it will have 1, while the y component for I is going to be 0. Now, if I look at the graph, I can see my unit vectors I and j and its magnitude. If I wanted to represent, let's say, OA, right? O is right over here and A point is right over here. Then I can directly look at its coordinates, which is A and 0, and put the unit vectors. I know x component is I and the value on the coordinate is A. Therefore, my value for that is going to be AI. However, I see that my y component is 0, so that's just going to be 0 for the j component, which is the y-axis. You can also think of it as being 0 j, right? When you multiply these together, you get the value of 0. So I don't even bother to write it. Now, just as an example, let's say I have the coordinates -3 and 8. And if I were to put this again, it would be -3i plus 8j. So right over here, it would be ai plus 0j. Now passing on to a question to understand it better. For position vectors OP and OQ and OR and OS with the coordinates that are given to me, and they want us to write each of these vectors using the unit vectors I and j. Now, starting with OP, I have the coordinates 1 and 2. Again, this is my x component, so that's going to be I. So it's going to be 1i, but I don't need to really write the 1 for it, so I'm just going to put I. And my y component is given to me as 2, so that's going to be plus 2j, right? Passing on to OQ, I have the coordinates -3 and 0. So for this, now I put the x component -3 and I put whatever the x represents, which is I, and then I do plus 0j, which you don't really need to write it like before, it's just going to become 0. Now we're passing on to OR, which I have a -4 and a -1. The x component given to me is -4, so that's going to be -4i. And don't forget the vector side on top for those. And the y component is -1, so I'm going to have negative in between them, so -1 j. But you don't really need to write that 1, so you can just do this. And for OS, I have 2 and -1, so I'm going to put that also. So that's just going to be 2i -j. Now the second portion is giving us the vectors, different vectors this time, in unit vector form. So I and j's are already there, and it's saying they have been already written using the unit vectors. Write them in component form now. So starting with OA, I have -i only. So I know I represent my x component and I have negative in front of it. So that means the constant I have for the x component, the magnitude of it is -1. Since I don't have any j value, the y component is just going to be 0. Passing on to OB, now I have an I value, which means it's only 1. So the x component is going to be 1 coordinate. And over here, I do have a j value. This means I do have something for the y component, which is 5. So it's going to be 5. Passing on to OC, again, I look at what I have for the x component, which is -5. And I look at what I have for the other one, the y component, and I have 2, +2. Passing on to OD, I see that I have √2i. So I take whatever the constant they given to us for I, right? So then my x is root 2, and what I have for the y value is -4. So that's it. Now, if I wanted to add two algebraic vectors meaning what we have been doing with I and Z, I add the x components together first, which is a plus c in this case, and then I add the y components together, just like shown over here. So an example to start out is given A equals OA, and which the coordinate is 1 and 3, and OB equaling to B, which the coordinates are 4 and -2, determine the components of A plus B and A minus B, and illustrate each of these vectors on the graph. So as for A plus B, I know my A has the coordinates 1 and 3, right? So I'll just put that first. And I need to add that to what I have for B, which is 4 and -2. What we saw before previously in the previous slide is when we are adding these together, I put the x values together first, and then I put the y values together. So that means put 1 plus 4 together, right? And then put the y values 3 and -2 together. This -2 is really 3 plus -2, but because it's negative, it just becomes 3 minus 2. And from here, I get the value of 5 and 1. And that will be my addition for A plus B. Now, in terms of A minus B, the value for A is the same, so 1, 3. But now I just put minus in between. And now I have 4 and -2. Again, I do the same things, x's are together and yz's together. But now when I put them together, I'm going to put the negative sign in between. So instead of saying 1 plus 4, which I had, I'm going to say 1 minus 4, right? And for the y component, it's going to become 3 minus -2, which will become 3 plus 2. So over here, what I'll have is -3, and a 3 plus 2 will give me 5. So if I want to graph it, first I'll draw what A vector looks like. So this is my A vector. This is going to be what B vector looks like. So this is B. And if I add them together like we did before, so adding A to like that will give me the resultant vector A plus B right over here. And I found that A plus B has a value of 5 and 1, right on there. Now A minus B has a value of -3 and 5 in terms of coordinates, so it will look something like this. So this would be A minus B. Now if I want to multiply my algebraic vector by a scalar, then I need to multiply the scalar with both x and y components. An example would be if, let's say, my scalar is 5, right? And I have the algebraic vector -3i and a plus 8z, right? Then I would distribute the scalar into both x and y components to get a value of -15i and plus 40j. So that's it. So previously we learned how to add these two coordinates together to find the coordinate of the resultant itself. However, if you want to find the magnitude of these two added together, then what we do is we add them in a way that x's are together. So you take x2, you do x2 minus x1 squared, and then you do y2 minus y1 squared and put them in a root. This here comes from the Pythagorean theorem. Normally, if you want to find the AB, just use this part right over here. But in terms of the magnitudes, that's what we use. So just to start out for an example, the coordinates are given to me for A, B, and C, which are 3 points in R squared. So this is considered in R squared also, so be careful with that. Calculate the value of AB plus BC and CA, the perimeter of triangle ABC. So first I'm going to find the magnitude of the AB given to me. I will directly put it inside of this. So I have root, and my x2 is not that. Let me label it so it's easier. This is my x1, this is my x2, this is my y1, and this is going to be my y2. From here, my x2 is 5, and I do minus my x1, which is -3, okay? And square this, plus whatever my y2 is, which is 22, minus my y1, which is 7. And make sure to square that. And if you plug in straight to your calculator, you'll get the value of 17 for the magnitude of AB. Passing on to magnitude for BC is the same thing we're going to do. Now we're going to take x1 as the one on B, and this is going to be my y1. Now because it's B to C, this is going to be my x2, and this is going to be my y2. Whatever the first letter is, count that as x1, y1. Whatever the second letter is, count that as x2 and y2. When I do that, I'm just going to go ahead and plug it in. When I do that, I get a value of 5 for this one, so I'm going to pass on to CA. Now, like I said, the first letter was going to be x1 and a y1, and the second letter is going to be my x2, y2 over here. When I do that, I get a value of root 242, and if you put that into your calculator, I get 15.56. Now, if I want to find the perimeter of the triangle, all I need to do is add the values I found together. So the perimeter is just going to be, when I add them all together, I get a value of 37.56. So that's it. If you have any questions concerning this video or any problems you would like us to solve, so we can give you a solution, you can always go to our website and go to our forum section to ask it.